Okay, so we have a multi-lens system problem. So multi-lens system problem. Okay, so that means we have more than one lens. We in these problems that we're doing here, or in these example problems, we'll be using two lenses. So let's say your first lens is +5 diopters, and let's say your second lens is +2 diopters. Okay, and I'm totally making these numbers up, but lens 1 is +5, lens 2 is +2. You have an object that is 100 centimeters in front of your first lens. So you have an object that is 100 centimeters in front of lens 1. Okay, and then let's say the distance between lens 1 and lens 2, let's say the distance between these two lenses is 10 centimeters. So distance between lens 1 and lens 2, let's say that is 10 centimeters. So this problem wants you to find where the image is located. Find the image location. Okay, so where do we start? Well, this really is a two-step problem. Okay, step 1, we'll be working with lens 1 only. Okay, and then step 2, we'll bring in lens 2. So, step 1. This is the key information that we have and that we'll be plugging in to this formula. What's the formula? U plus D equals V, or U1 plus D1 equals V1. And we're only putting the ones under each of these letters because we have two lenses in this problem, and these two lenses will be using this formula. So the same way we're using this formula for lens 1, later on when we're doing lens 2, we'll be using this formula as well. So just to make everything nice and organized, we're just going to go ahead and put ones under U, D, and V for lens 1, and then 2's U2 plus D2 equals V2 when we get to lens 2 later on. Okay, so U1 plus D1 equals V1. Well, let's go ahead and chop it up into 3 different pieces. We'll do U1 first, then D1, which will give us V1. So we'll start with U1. What is U? What's U? So U is your object power. The power coming from the object, the vergence coming from the object, how much power is coming from the object. And the formula for U is 100 centimeters over small u1. Now small u1 is the object distance in front of the lens, okay, and which is given in the problem. So the object is what distance in front of the lens? It's 100 centimeters in front of the lens. So u1 equals 100. So 100 over 100, or simply 1. Is that one positive? Is it negative? Well, we have to look back at this. So the object is 100 centimeters. The key word here is in front. The object is 100 centimeters in front of lens 1. What do we know about light rays, or light in general? Light travels from left to right. All light travel from left to right. Okay, and once they pass some kind of media, let's say a lens for example, anything in front of this lens, this whole space in front of this lens, that would be negative. Okay, negative space. Anything behind this lens here is positive space. Okay, so in our problem here, the object is in front of the lens. It's a negative space, and it's 100 centimeters negative. So that would be a negative 100. 100 divided by a negative 100, our u equals negative 1. So at this point, we're totally done with u. Now, we're going to move on to d. So what's d? Your d is the lens of the power. Since we're doing lens 1, the power of the lens, or the diopter value of the lens, is given for us. It's plus 5. So d equals plus 5. Okay, and so to find v, we just add u, which is negative 1, and d, which is positive 5. Once we add negative 1 and positive 5, we get v1. This gives us 4. And the whole purpose of finding v1 is to plug it into this formula, which is very similar actually to this formula, because you're finding, or you're looking for similar things here. Okay, where u was your object, what you were looking for was the object distance. V, you're looking for the image distance, or the image location. So you're using the same formula here, 100 divided by small v1. Okay, and we're just going to plug in v1 for what we just got here, for v1. So 100 divided by 4, or 25.25 meters. Or 100, or I mean 25 centimeters. Or, whoops, actually let me just go ahead and just go back. I did my math wrong here. So 100 divided by 4 is just 25 centimeters. Okay, so your image location is 25 centimeters. That's your image location. And we're nearly done with the first step here in lens 1, so we'll be moving on to lens 2 in just a second. Before we do that, we have to find our focal points. So we use our d value, or diopter value, to find our focal points. And so how do we find it? Very simple. You go ahead and you do this problem, or this formula. Use this formula. So our focal point f is equal to 1 over our lens power. In this case, our lens power is 5, positive plus 5. So 1 over 5 is 20, and this is in centimeters, 20 centimeters. Of course, that's plus and minus 20 centimeters because we're looking for 2 points, focal point 1 and focal point 2. So focal point 1 is equal to our negative value, minus 20 centimeters, and focal point 2 is equal to our positive value, or plus 20 centimeters. So now we have just about everything we need to make our drawing. Okay, so let's go ahead and let's begin our drawing. Of course, our drawing won't be complete until we have our lens 2 values. But let's just go ahead and start it anyway. So we have a lens. Well, let's go ahead and start with the object first. Okay, where are we going to put the object? Well, we said the object was what? The object is 100 centimeters. So let's just put the object 100 centimeters in front of the lens. So first we have to draw the lens. Okay, so our lens is plus 5. It's a plus lens, which means it's a convex lens. Convex or plus lens in this case is plus 5. Okay, our object is 100 centimeters in front of the lens here. So let's put it all the way out here somewhere. This is 100 centimeters minus, because it's in minus space or negative space, and this is our object. Okay, now what else do we have? Well, we have our 2 focal points, which are 20 centimeters. So let's be kind of realistic. Let's say 20 centimeters is there, which is probably a little too far, but let's say this is 20 centimeters and that's 20 centimeters. If this is our negative space, that's focal point 1, because focal point 1 is negative. So negative 20 centimeters is focal point 1. Focal point 2 is positive, so we're in positive space now. This is focal point 2. Okay, so we have our lens, we have our focal points, we have our object. What else can we draw right now? What other information do we have? Okay, so we also know, well, we can move on to lens 2 in just a second, but all we know about lens 2 is what? We know 2 things. That it's 2 diopters. Lens 2, the power of lens 2 is 2 diopters, and the distance between lens 2 from lens 1 is 10 centimeters. Okay, so if this is 20 centimeters, the second lens is like halfway. It's like maybe here. So we're just going to go ahead and draw another convex lens because it's plus. It's a plus lens. Okay, and that space there is about 10 centimeters. Okay, so let's just go ahead and stop here, and we're gonna do the second half in another video. Okay.